Waves, the fundamental concept of wave is a mode of energy transfer. It's a concept of transferring energy. Wave is a disturbance which moves, and wave is a mode of energy transfer. Waves transfer energy without transferring matter. Waves transfer energy without transferring matter. The basic classification of waves, there are two types of waves. One are called mechanical and second are called electromagnetic. Now, the mechanical waves are those which need a material medium to travel on, and they cannot travel without a material medium, like water waves cannot travel without water. Now, right under it, that electromagnetic waves are those which can travel through space as they do not need any material medium like light. So electromagnetic waves are those which can travel without a material medium. You have to copy this screen.
I've copied it.
Good. Second classification of waves.
Do I have to give this heading?
Yes, give this heading. Second classification.
Done.
Now, there are two types of waves. One are called transverse waves and second are called longitudinal waves. You have to copy this heading.
Done.
Now, give the heading transverse waves.
Done.
Now, this is the definition. The waves in which oscillations are perpendicular to the direction of propagation of waves. this is the concept that the wave travels horizontally and the particles are moving up and down. These are called these are called transverse waves. So give the heading transverse waves and then copy the definition. This definition comes in paper oftenly.
Done.
Now, this is the example. This is called a ripple tank, and the water is moving in a ripple tank. When water moves in the ripple tank, the cork is moving up and down. This is an example of the idea that transverse waves travel in a straight line. So any particle on the wave will move up and down. This is a transverse wave. Now, what happens in a transverse wave? Every particle goes up, every particle goes up, come down. It is like a disturbance which is moving. So transverse wave is actually a wave in which particles are moving perpendicular to the wave. Now we have some famous examples: waves in water, waves in a rope. All the electromagnetic waves are transferred. Seismic S waves, secondary waves. Seismic S wave, this topic came in the latest wave syllabus, the last to 2022. You have to copy the list of transverse waves.
Done.
Seismic waves are also called secondary waves, and shear waves are the second waves to hit the seismographs. These are the waves which travel under the earth. These are the waves which are called underground waves. And these waves are shock waves. And may God not, when earthquake comes, these waves travel in the earth and they are capable of producing shakes. Now look at this animation. This animation gives a very good concept that what is a transverse wave. Every particle is jumping on its turn. Every particle jump on its turn, but no particle sweep away with the wave. So this is called a transverse wave. A transverse wave is actually a disturbance which moves. It is a wave in which particles move up and down, but they do not go with the wave. This is a long spring. Look the shaking of the spring. This is called a transverse wave. So a transverse wave is actually a wave in which oscillations are perpendicular. Now give the heading, important terms in transverse waves.
Done.
These are the important terms. You have to copy this list now.
Done.
Now, putting the first one, displacement. Now, what is displacement? Displacement is the separation from the mean position. In this chapter, we are going to use simple graphs, and it would be ideal that you should use a ruler and pencil, and because graphs should be a bit neat, and this is a graph of distance against displacement. So write under it number one, displacement. You have to copy this.
Done.
Now, distance is the general terminology. Distance means how long the wave travels. And then amplitude, give the heading amplitude. It is also called intensity.
done,
Now, what is amplitude? Amplitude is the maximum distance from the mean position. It is actually the height of a wave. It is actually the height of a wave. Just like here, if you remember loudspeaker, amplitude is the loudness. This is the height. So when a wave is traveling, look at this wave, and a wave is traveling. This is called amplitude. When a wave is traveling, it is the height of a wave. Amplitude is the height of a wave. So after giving the heading amplitude, right under it, that amplitude is the maximum distance, copy this, from the mean position.
done,
Now look at this screen and you have to copy this graph.
Is it the same one as the previous?
Graph is the same, but marking is different. So amplitude, amplitude is the height of a wave.
Done,
Now look at this screen. This is the amplitude, and we have a concept that greater the height of a wave, greater is the energy transfer. This is why in all tsunami videos, you will see very, very high waves. So amplitude is a measure of intensity of a wave. So this is our next concept, that amplitude is a measure of the intensity of a wave. Then you have to copy this screen. Amplitude intensity is a measure of energy transferred by a wave
Done.
Now, give a new heading, number 4, wavelength. Now, what is wavelength? Let's make our concept. When a wave is traveling, it is the distance between two consecutive crests or two consecutive trough. Look at this diagram. So wavelength is the separation between two consecutive trough or two consecutive crests. So you have to give the heading wavelength and its symbol is this sign. What is the, how we read this sign?
Lambda.
Lambda, very good. You have to copy this.
Done.
Then you have to copy the definition.
Done.
Now, you have to copy this screen. The how we represent wavelength on a wave.
Done.
This is the pattern and this is the concept that how we represent wavelength. Wavelength is actually the separation between two consecutive trough or two consecutive crests. This is called wavelength. Wavelength is actually one cycle of a wave. Now give the heading time period, capital T. Now, what is time period? Do you remember from your earlier classes work? What is time period?
The amount of time taken for a wave to complete one cycle.
Yes, we did this from our topic of pendulum also. It is the time required to complete one wave cycle. It is the time of one wave cycle.
Done.
Now look at the axis. Now this time axis is time. On x-axis, we are putting time. This time it is not distance. Displacement against distance graph and displacement against time graph. So it is a separation. Measurement is the same as the wavelength, but x-axis is time. You have to copy this.
Done.
Now you have to specifically note that x-axis is time. In the previous graph, look at this graph, the x-axis was distance. Now this is to understand that when x-axis is distance, it is wavelength. And when x-axis is time, it is the time period. Now give the heading frequency.
Done.
Now, look at the definition. Frequency is the number of wavelengths that pass a point per unit time. It is the number of cycles in 1 second. So you have to copy the definition.
Done.
Formula F is equal to number of cycles upon time in second. And we did it when we were discussing CRO. This is a repetition of that formula. So copy the screen, the formulas.
Done.
Look at the unit. The unit of frequency is hertz. 1 mega. Mega means always 10 power 6. You have to remember these prefixes. And 1 megahertz is equal to 10 power 6 hertz. So learn all the prefixes. You have to copy this.
Done.
Now look at this type of question. What is the frequency of the wave? You should always look for the time period, and 1 upon time period is frequency. What is the time period of this signal? Look at the graph, and what is the time period? Time period means time for one complete cycle. So if you look at the screen, what is the time for one cycle? This is one cycle. Then the time period would be 2 seconds. Once you get the time period, the formula for frequency is 1 upon t. So 1 upon 2. 1 upon 2 means 0.5 hertz. So the answer would be B. Did you get this example? Zainab, can you hear me?
How is it 2 seconds for one cycle?
2, 2 is on the x-axis. Now look at the time for one cycle. Look at the
Oh,
graph.
okay. I get it now.
Now give the heading speed of a wave.
Done.
Now see the formula. V is equal to F lambda. V is equal to speed of, this is a very important formula, and it comes very regularly. It comes in nearly every paper. Now, copy this screen.
Done.
This is the formula we use in our calculations. As I mentioned, these calculations are very important. And here, again, I repeat that you should always try to learn. You always have to try to learn the, you have to try to learn the prefixes. Prefixes are very important, and prefixes are part of unit, like meter, kilometer, mega, kilo, giga. I think I had shared a prefixes list with you.
Yes.
Right under it, that in a bracket, learn the prefixes. Learn the prefixes. The prefixes are very important to learn. Then copy this screen. This is another formula. What is the speed of the water wave? Now read this question. Now, how we can solve this question? I have shared the prefixes with you, and I'm not sure if I have shared before or not, but prefixes, I think I had told you to copy also when we were doing chapter number 1, but prefixes are very important for conversions. The formula is V is equal to F lambda. Left graph is in distance, so you have to read for the wavelength from the first graph. This is the lambda. This is the lambda. Lambda is 2 centimeter. Now look at the right graph, right side graph, and it is 1 cycle, and 1 cycle is time period 0.04 second. Now, should I keep the lambda in centimeter, or should I convert into meter? Please reply.
The unit of wavelength is meters.
The unit of wavelength is meter. So how should I make the calculation now? V is equal to F lambda. And I have another formula which I should apply. V
Lambda over time.
is lambda over T. So V is equal to, what is lambda? 2 centimeter, 2 into 10 to the power minus 2 upon 0.04. So can you do the calculation, please?
Why did you read 2 into 10 raised to power minus 2?
Centimeter to meter.
Is it not divide by 100?
The same thing. You can divide it by, it's the same thing. You can divide it 2 divided by 100, it will be 0.02 meter. Now do this calculation.
Zero
Acha,
point.
there is a trick. All answers are in centimeter. Look at the question.
Yes. That's what I was thinking that
Sorry,
should
you
we
didn't.
convert or not?
I overlooked it. He was tricking me, and I didn't see it. It's 2 upon 0.04 because the answer has to come in centimeter per second.
So it depends on the question. Either we need to convert or not.
Especially in MCQ. Normally in paper 2, conversion is there. So it will be 200 upon
50.
200 upon 4 means 50. Now, wavefront, give the heading.
Done.
Wavefront is a surface which travels with the wave containing oscillations exactly in phase. In a concept base, this is a geometrical representation of a wave. Wavefront is like when we show the Wi-Fi signals on a mobile phone, there is an icon which is a curves. So this is a geometrical representation of a wave. Like these are the geometrical representation of a signal. So when we draw wavefronts, we actually show the wave like we draw in electric field, some virtual lines. We draw magnetic field, we draw lines. Similarly, we have to show a wave. So in order to show a wave, we draw virtual lines like this. These are called wavefronts. So after giving the heading, first give the heading wavefront and then copy this. I'm just coming, copy this heading. So write under it that this is a geometrical representation of a wave. You have to. So when you draw lines in an electric field, this is a geometrical representation. So this is a geometrical representation of a wave like this. So now you have to copy this. So these curves, these lines are called wave fronts. What is the
Done.
This is called wavelength from the wave, and these wavefronts can be vertical, these wavefronts can be circular, these wavefronts can take different shapes. So when you draw wavefronts, they can take different geometrical shape. Now give the heading ripple tank.
Done.
Ripple tank, we will discuss it in our next class. We, as mentioned,